Okay, welcome back. The last lecture was a bit quiet, so maybe this one will be too loud. We'll see. This is our first lecture, actually, about the class. So, AI for gameplay. What is AI? Well, I'm not sure. Artificial intelligence, or AI, right, is a term coined at some point in the last 50, 60 years of computer science, really trying to sort of quantify this concept of intelligence as if we actually know what intelligence is in the first place. But and again, sort of projecting the sort of like bio-chauvinistic view that we somehow being biological means that we're intelligent versus non, and that anything that we create that is intelligent may be artificial in nature. So deep question. What is AI? So let's not even talk about what is AI. Let's talk about game AI. And let's talk about working in game AI. And we'll ignore the concept of intelligence for some time, right? But I'm assuming everybody in this course has played a game. And I'm sure you all noticed these other entities in the game that are running around. Those entities may be controlled by other users that are over a network. But some of them are not, right? Some of them are controlled by your own local computer, maybe some compute resource in the cloud or wherever it might be. And these are computing systems that are making decisions based on what you're doing and based on maybe a previous set of instructions or perhaps some kind of algorithm. This is what we would kind of designate as a game AI. And if you've played a game, those dynamics of a game and the way that you interact with the game really kind of define it in many ways. And it's a little bit interesting because this isn't maybe something that people really think about when they're playing a game. You don't think about the sort of heuristics and the algorithms that were used to generate the environment that you're in, or those algorithms that kind of dictate how that environment responds to you, both in terms of these entities as well as the environment itself. But all of that we would kind of put into the bucket of AI, of artificial intelligence. And it's a little bit of an underappreciated field because even in large AAA games, often you have a very small team of 3 to 4 person AI teams. There's a lot of, confusion about what that means and what that team is building and how does that, interplay with the rest of the game, and then how, and in particular the game development team. In fact, like some games really don't have any AI developers at all. I mean, this is probably every indie game ever, right? Obviously, there's AI in the game, but you couldn't point to one developer on the team and say that person did the AI. Because AI is this broad term that covers, like, for example, in Minecraft, okay, you've got the AI of the other things in there, like the whatever, the zombie, the crawlers or whatever, but you also have the environment, the procedurally generated environment that you're in, which is an AI algorithm, right? That is determining what that is going to look like procedurally before you even get there in a deterministic way, so that you don't go back to the same place and it's changed the next time, right? So there's well, not that that's what happens in Minecraft, but whatever, you get what I'm saying. So this is not necessarily something that people take a boundary around, and so it's quite broad and ill-defined, right? So to go through a few of these things, I already mentioned some, right? We just the procedural generation of anything is AI. So if you're playing like No Man's Sky, everything from the planets to the creatures themselves, that is an artificial intelligence process that determines what those things are. So when you play the game, those are determined before when you actually arrive at those places or see those things. Tactical and strategic military, NPC AI, right? Like you're playing a game, and how does the other enemy maneuver its troops and respond to your actions and perhaps the actions of other entities in the game. We've got things like genetic algorithms to balance the game. So sometimes you were using AI to actually design games in the first place, so you don't even see the AI because it's done before they even ship the game. AI directors, which are essentially the directing the behavior of different agents in the game, and We've got neural networks now. This is starting to actually happen in shipping games, right? Like if you're familiar with DLSS or deep learning super sampling, that this is now a production quality technology that is being shipped with NVIDIA GPUs and is being used in a number of AAA games where they're super sampling, which is a machine learning version of temporal anti-aliasing that allows you to render at one resolution and then upscale that in a very, very intelligent way to a higher resolution. It's quite amazing, right? And anybody who's done any kind of graphics knows if you have to render fewer pixels, you can render more things, or you can have a higher fidelity rendering. So it's a really exciting thing. Reinforcement learning is starting to make its way into games, both in terms of training of these policies that then become the AI decision-making entity in the game, as well as RL being applied again for the design of games. So for example, EA recently put out a paper, a demonstration of RL used to test games. So you can sort of find vulnerabilities or problems with your game in a kind of mass way, in a way that would take thousands, if not millions, of human hours. And even then you might not find them because they're so weird and archaic that a human being might not ever try those sequence of behaviors. And then kind of more in a more practical sense, ML for cheat detection. And actually more recently, what's cool about this is folks are using machine learning and AI for toxicity detection and aversion, or the ability to detect when there's a toxic thing happening and sort of interjecting in the game at that moment to stop that interaction or intervening in some kind of way. In fact, Unity just acquired a company called OTO that does that with audio, and there's a company called Good Game Well Played that's doing that for chat. And as many of you all know, games can brew some toxic environments, and so this is very kind of aligned like with bully detection and just general negativity on the internet and places where your actions don't have direct repercussions on you. I think is going to be a more and more important aspect of the field as we move forward, because more and more things are happening in virtual environments such as Roblox and so on, and it's very hard to stop toxicity from really festering in those environments. So we've talked about all these amazing things that AI can do, but it's not everywhere, and it really does make the difference between a really good game and not a good game. And honestly, if you take any game that's great, it usually comes along with great AI, but it's not always the same way around. Like, it's not always like, here's a great AI and it produces a great game. So the question is, all right, why isn't AI everywhere? All right, like why don't we see it everywhere we look? Why isn't it more invested in? Why don't we have more of it, more teams, more definition in these? Why don't we have like specifically AI game development majors and things like that? And folks that usually are interested in AI don't do it through the game development path. They often go through the academic path in terms of just traditional ML AI kind of studies, like reinforcement learning, for example. And why is that? So let's go through a few reasons, right? One, and I think this is probably the most important one, is just like when you're making a game, you don't think that about the AI. You just think about the game you want to make. And it's not like you sit there and like, oh, I wonder if I do this cool technique, like that's going to make the game better. That doesn't happen, right? Most of the time you have this idea for a vision, and the team has kind of a goal, and the AI sort of gets kind of kludged on at the end or something like that. So, what game is there where the AI was the motivating factor? And I think there are some. I'm not familiar with them. There are games that the sort of decision tree and the behavioral tree and the decisions you make ultimately determine what can come to you next. I think those games are kind of maybe popular in the indie world. I don't play them personally, but I've seen some of this, right? Like in these sort of dialogue narrative based games. But even there, it's barely AI. It's mostly just sort of a narrative tree that if you choose one path, you end up going down that path. And while that's formally a version of AI, I think it's much more designed, and we'll talk about that in a second, the ability to control the design of AI. And one of the reasons it doesn't get invested in is because true AI is unpredictable, and when you're making a game, you kind of want predictability. So this is probably obvious. It's making AI that doesn't suck. It takes a lot of commitment. It takes a lot of resources. And we're making a game, right? It's pretty hard to justify that in lieu of having a game that you know is going to sell. And then by the time you've shipped it, well, you've shipped the game. Now the game's making money, and you just want to pour gas on the fire and keep that going. So this is also kind of known as innovator's dilemma, right? You're taking away by working on AI, you're taking resources away from sort of the bottom line, but from the resources you know are needed for actually selling a successful game. So it's just sort of a tug of war. This AI is not the only thing that is true here with game development or any kind of product development, but this is definitely one of the limiting factors. Sort of similar to the last one. Often resources are scarce. Resources are scared. They are scared. Resources are very scary, scared of things. They're very, very timid. This is true. Sorry for the typo. But resources are scarce, and often AI, and yeah, AI is not the only thing that gets cut back, right? You just kind of deal with a sort of 80-20 rule where only 20% of a product tends to deliver about 80% of the value to the end user. And so very often AI is on the cutting block, along with other things, certainly, but it's not considered, like, people don't like to cut graphics, for example, and folks don't like to cut animation or audio things because those are directly related to maybe success of the game in terms of the user experience. And so AI has there's a lot more like workarounds and shortcuts that you can take in those scenarios, and that's often what happens. This is kind of true, right? Where new capabilities don't really like show results. Like, how do you prove an AI is better than a previous AI, right? You can't really prove to me that this AI system is fundamentally better than the previous AI system. It's very difficult to do. Whereas, showing a new graphics algorithm that runs, gets 10% more frames per second, you can just show me, hey, this runs 10% faster than the previous, or this looks 10% better because we can do, better, specular reflections or whatever it might be. So this is a problem with AI. There's no way to like really demonstrate it. And as a result, it's hard to, get the support to justify doing new things. Reason 5, it's difficult to test. AI, like by definition, like a good AI is stochastic and kind of random and has a lot of coverage, and really, really good AI attributes some non-zero probability to almost every possible option in the space of options that is available to it, and that means a very large search space, and that's generally not very tractable. I actually don't have experience with black and white, but this was in the slide before, and this is true. Many games need to create kind of these bespoke solutions to test almost every combinatorial every combo of different combinations of things that create these systems to make sure that none of them have a bug or expose some kind of fragility in the engine. It's pretty common for things even like No Man's Sky. They had to I remember the story. They had to essentially create a player that visited every possible one of quintillion combinations of things just to keep running and hope and test the engine to make sure it didn't crash. So it's even when you can do it sort of from a heuristic standpoint, it's not necessarily tractable as you create kind of a deeper experience for the user. So it's tough. 6, this is true, very true. Unfortunately, making games the games are media in some form or fashion, right? You're telling a story, you're trying to convey an emotion, you're trying to give people experience of some kind, and you have designers, understandably, that want to create an experience that is sort of predictable. You want to have creative control, right? Say you have a bunch of AIs it's like a Viking game, and you have all these angry Vikings in a hall, and the game you want to walk in and they all get angry at you at the same time and do kind of angry things, and then one of them like just decides to go and start doing like a polka dance or something. Like you don't want that to happen. That might be a general AI because there is a non-zero likelihood of that happening, but you want to have control. You want to make sure that these things kind of do what you want them to do, right? Just like if a movie director, tells actors exactly what to do, and they work within this sort of cone of possibility, but they don't go off and do something completely unexpected, because if they did, then it would, break that, what's it called? The suspension of disbelief, right? Which I think a lot of entertainment experiences really try to cultivate. So it's difficult. It's not trivial to do. And another kind of point about this, right? You have procedural generation or artificial intelligence behaviors that may not actually be replayable because of that stochastic nature. And if you have an experience or a procedure or a process in a game, being able to sort of, mix in deterministic expected behaviors with non-deterministic sort of stochastic open-ended behaviors is a really hard design problem. And often designers will just say, well, fuck the AI, let's just, do a behavior tree or a node-based sort of action sequence, right? So this is something to kind of think about, right? This one's a little, I think, arbitrary, but it's true. AI is just not solved, and I don't think it ever will be solved. And when it is, we're not going to be, talking about it this way. And the middleware sort of helps, but it doesn't really help. Often, if you're building even just something simple like pathfinding, it's very specific to the game and underlying implementation. There's a recent set of threads on Twitter that we're talking about, like the original Skyrim game, and one of the really notable, interesting ones I found was about how apparently if you followed the foxes in the game, following the foxes would lead you to treasure. It would always lead you to treasure, and the reason was, and it's very it kind of exemplifies this flaw, is in Skyrim they had a number of different sort of pathfinding mechanisms for a variety of different things. If you have something that's, really important, like combat, like, you're getting attacked by a bandit or something, those bandits had really kind of high compute pathfinding enabled, because it needs to be where you are and that kind of thing, and be able to chase you or run away or what have you in a very kind of intelligent fashion. You don't want it to go running through walls just because that was like the path it was on. There was a sort of low tier of pathfinding that was used for sort of like, call it merchants that don't interact with the user very much. They're just kind of walking. When you walk up to them, you talk to them, they stop, right? And they're just following kind of the set path through the environment, and sort of, getting pushed and nudged around a little bit. But for the most part, it's a sort of set expected path. But there was this kind of middle tier, and this middle tier sort of just dealt in the triangles of the nav mesh of the environment, right? So the high performance tier would actually look at the space in the triangles, but the middle and the low tier didn't do any of that, right? It just followed these segments. But the middle tier would look at the number of triangles. And if you think about a game like Skyrim, it's quite expansive, and you've got these regions of the world which are just kind of flat and there's not much going on. And so there's these large triangles that in the nav mesh, but as you get closer to interesting points of interest, such as like a bandit camp that the game wants to encourage you to explore these places. If you explore, you eventually bump into these interesting places, and there's treasure there, and that's the motivation. These areas had a lot of triangles because of a lot of complex kind of topography and so on. And so this middle tier AI pathfinding system was basically counting triangles and trying to navigate, based on this kind of triangle counting. And guess what happens? Like, it would automatically go, so try to seek out, these areas of high density of triangles, because that's a very quick way to find very small triangles, a lot of triangles in a short path. And so what would happen is every time you came across a fox or something, it would run away, and the path that it took was in the direction of treasure, of these areas of interest. So it kind of shows just how this very unintentional thing led to essentially a complete exploit of the game that people kind of figured out. It's like a kind of quirky, delightful thing, right? But clearly not something that the game developers intended to happen. So this one's actually a pretty deep subject. This one is true, although it's fluid, I think, and it's true, like, what is gameplay, what is AI, and what's the difference, what is AI building? But to be fair, like, this is a problem in like almost every software company. Like, what do you do? What do I do? Like, people asking you to fix the Wi-Fi and shit like that. So there is a kind of a open-ended nature to AI development. And are you building tools? Are you building AIs themselves? Are you building, like natural language processing flows for generating new text sequences? I don't know. It's kind of open-ended, but this one I'm less worried about, because if you have a real conversation with your company, you can probably figure it out. This is, I kind of touched on this before. Game developers, apart from yourselves, you guys are all getting a academic background in, game development, and now AI, right? But often game developers, and I think this is true of the industry as whole, like, you've got all kinds of folks from all walks of life, in particular in game development. People get really excited about games, find their path into the industry through QA. You can build a game without a particularly strong background in computer science and kind of get there, which is, I personally, I don't think is a great thing, but there's some of the best game developers I know, like, dropped out of high school, right? So this is fine, but it especially in a field that is as quickly moving as AI. Like I mentioned in the beginning, some of the things that AI and ML can do today are like just seriously science fiction. Like these are things that shouldn't be possible. And it's kind of crazy because it's not about the techniques. There's not like anything new. It's not like we invent some new computer science and all of a sudden now we can do things we couldn't do before. It's all the same computer science. It's just a matter of being open-minded in a way that was not really done, with lower compute, and who knows where that ends and if it ends at all. So there's just the science fiction thing going on with AI, and a lot of game developers and more traditional software developers that haven't, taken the plunge yet. And this is something a lot of folks bump into. I've dealt with this. One of the guys that I worked with at Unity worked at Hearthstone in reinforcement learning. And I talked to both him and the guy he worked for, right, who was the game designer, and kind of hearing their respective take on the reinforcement learning stuff that they were doing is very interesting, right? Because, the RL guy, brilliant guy, right, was complaining about how just difficult it was to get game developers to buy into anything that they were trying to do, right? Anything that required some kind of development or integration, given the resource constraints of the game development environment, as we were talking about before. Yet the other side, the guy who's designing the game and making sure it's getting shipped and providing and delivering a good user experience, was complaining about how the reinforcement learning and the AI stuff just wasn't fundamentally stable enough to integrate, because it did things that they didn't expect, and it kind of, again, all the reasons we're talking about here. So this is a tug of war, and more education is the only way to really solve this problem, because while AI systems are science fiction and really amazing, they are limited. They can't do everything. We still haven't really cracked the intelligence in artificial intelligence. Right now we have, very intelligent seeming systems, very narrow AI, things that can sort of interpolate or in some cases extrapolate, but not doing both. And that's a whole ball of wax to whatever the saying goes. But so this is actually a bigger deal than you might expect. You're going to bump into this. As soon as you bring up AI, you might start a flame war. So be aware that AI doesn't mean the same thing to everybody. And the best way to deal with that is just to have an open dialogue and learn more about it. And I kind of mentioned this a bunch of times already, but one of the big reasons, AI doesn't sell games, right? Games sell games. Like when you're making a game, you're not making AI, you're not making graphics, you're not making an engine, you're not making networking stacks. You're building something that users are going to use and love and give them an emotional and experiential type of period of time that they're going to spend with it. And so if it's not the most noticeable thing, it may make the difference for some small niche group of people. Some people might notice, some people might not. So it's very difficult to really, get excited about something that people don't just like wake up and be like, wow, that game was amazing because of the AI. So, and this is actually not just true about AI, but I think a lot of techniques that are true in academia, like just a lot of the techniques we're talking about, right? Like I'd love to use transformers for, these natural language level generation of dialogue in games. Like, I mean, I'm sure you all have seen GPT-3 and the things that it can generate, and these like fluid seeming sentences that just sound like a human being is speaking. The problem is GPT-3 is like 500 billion parameters. Like it's like, it can't even fit on a hard drive. So it's a lot of the things that are kind of, call it state of the art, are also, as a result, very much not production possible. This is going to change rapidly during your career, I think. And I mentioned this in 797 as well. I think being on the sort of paying attention to AI and machine learning is like the most important thing you could do today. Eventually, these things will come to dominate and even eat entirely these things like ML-generated graphics, ML-generated, obviously, AI. This is going to be, I think, the de facto way to do things. It's not going to say that, engineering is going to go away. It's building these are engineering systems, and obviously there's a lot to be said there. And while this is not a machine learning, deep learning course that I can go and prophesize about these things too much, right? One of the things to think about in terms of machine learning is that you're taking this sort of unbound thing. You're taking this very complex function, or like the function of a decision made in an environment of like, should I eat the apple or not? That's a function. That's a yes or no. Taking that, mapping that into a bound type of compute. It's sort of like rendering, right? Rendering is this unbound thing. If you look at the rendering equation, it's this big open integral that includes the entire universe. You have to basically render everything to even know what things look like, and you can do that forever and still not get the right answer. But if you have enough data to train an ML network to sort of figure out what that function is abstractly complex and just impossible, right? But we can actually learn it within a bound compute budget to an arbitrary degree of accuracy. And now you've taken this open-ended function and turned it into a set number of computer cycles. And granted, it's not going to be perfect, but it's going to be close. And at one point, what point is the approximation good enough? Or what point is the approximation so good that you can't even notice the difference? And this is likely, to some degree, how our brain works and how we project, reality into some form of consciousness as well, right? Because ultimately, we cannot consume every bit of information that we come across. It has to be represented in some interesting way and then stuffed into a bound amount of computational power that is limited by the number of, things that are happening in our head. So this one kind of got away from me. I kind of went on a tangent there, but yeah, one of the things to kind of pay attention to here is today, a lot of these techniques are not possible for production game development, and you're going to have to deal with that headwind, but that is changing rapidly, like on a daily kind of cadence. Things that we thought were not possible are now possible. Things that we thought were going to take months and months and months are now going to be done in a minute on your phone. So it's just it's a very rapid place to kind of be experiencing the movement of technology. So what can you do? And honestly, you can do anything you want, right? But go with some ideas. If you want to do AI in the context of the game development industry, here's some options, right? You can be a gameplay programmer, a tech designer. You can go indie and build your own game and do this stuff. You can do military, and honestly, that is probably one of the most active areas if you're doing AI in simulation, military. While I didn't have clearance to know what the hell they were working on, at Unity we had a large group in Orlando doing exactly that. I personally do not like working on things that might potentially kill people, but if that's your jam, you should do it. You can work on teams that sell games based on AI. This is, kind of going in through the side door, I suppose. You can use AI in inventive ways. That's always a good idea. This is actually test your game balance. This is a big one, especially if you have like economy-based games or like inventory matching and like balancing and things like that. There's a lot of value there. In particular, a lot of the places that AI is used is in predicting the impact to a large user base given an economy-based game. Right, so you have a game with like a MMO with an economy, and you're going to add some tweaks. So there's a new season coming out of a large game, and you want to know potentially or predict what will happen. So that's a big area that people really want this stuff. Animation, we're probably not going to talk about too much of like rigging and animation, but for example, there are things like in-betweening, and being able to generate really kind of believable, physically accurate, or just in generally artistically correct in between frames of animation, because an animator is limited essentially by the keyframes that they produce, right? They're not physically moving these bodies; they're kind of rigging them in interesting ways, and so being able to train a network, like a machine learning network, to output, correct, like as if an artist positioned that body, that rig, and then applying that to a set of keyframes allows you to get some much more realistic looking animation. It's also about animation interpolation. So interpolating animations in a non-linear way, you can take two animations and sort of morph one into the other, right? Like a person doing this and a person doing that. And so maybe you don't want them to go, doing this weird dance. You actually want them to move their arm first and kind of go into a believable pose and then move into the next one. And sure, this is what artists can do, but maybe you don't have an artist. And so you can use these machine learning networks to essentially interpolate different animations by taking animations that are known, projecting them into a space, and then interpolating in the space and then projecting them back. And then you can actually have a correct position at all points and actually meld these two unrelated animations into one another, but they don't just look like, morphed things. So this is cool. If you're interested in that, Ubisoft has a project called like Deep Pose, and some really cool use cases. Maybe we can go through them in the class. Very fun things. Automating a game task with AI. This is a very open-ended thing, but yes, AI is a great way to automate things once you kind of really have the answer to them. If you have a problem and the answer, and it takes time, you can automate it with AI. Cheat detection. The problem with cheat detection is as soon as you do it, somebody finds a way around it. AI may be a way to do it in a more general way where you can constantly update your cheat detection algorithm in a way that can foil cheat software. Get in a power position and make them do it. Yeah, sure, you can you can get lucky. So what is the point? Like, why is AI good? Right. One of the things I think that is probably the most valuable bits of AI, just like multiplayer games, you can play forever because you're always going to be playing against a unique individual somewhere. Replay value, right? If you have a real AI that is doing interesting things, you're going to come back to the game over and over again just to find out what's changed. And this is, I think, a big one. It's one that's sort of been undelivered so far. I think most AIs do not provide replay value fundamentally, but we're definitely, I hope to see that in the future. Provides more choice in how the game is played and gameplay depth. This is true, right? Having sort of a wider tree of possibilities and choices made possible by AI that sort of, randomizes things to kind of a, bound degree is a very, very valuable thing. It makes these games wider, more interesting, more deep, and also challenges the user, right? Like, for example, having an AI system that determines automatically the difficulty level that the user should be playing with and constantly trying to match the skill of the user, the skill of the player to the difficulty setting of the game. And humor in general, enhanced entertainment value. This is true. A lot of AI is hilarious and does silly things. Maybe I'll post on the Discord a very, very funny example of I think it was like Miyazaki, like reacting to AI animation and making these AI researchers cry. So, it's all within reach. AI is definitely kind of like the next big leap for games, and I didn't really talk about the deep learning stuff and the AI stuff that is in the context of generating game assets and generating environments and things like that. That's more of my other course. But there is a lot to be said about how machine learning and AI can come in and really fundamentally change the nature of games, both in terms of gameplay, in terms of look and feel, in terms of the experiential value. And so it's definitely making things better, but it's just sort of undervalued. This is going to be kind of a quick rapid fire of a few examples that I encourage you all to check out. This is really fun. Check out this YouTube video. Reinforcement learning was applied to Blade and Soul in kind of this competition format. So you have these two AIs fighting each other and trying to win. And so it kind of shows just how far, this goes. Actually, it might even be that the agent's playing against a human player in some cases. And so this is cool. It's similar to like the Dota 2 and the StarCraft AIs out of OpenAI and DeepMind, respectively. And so there's some really cool examples of real AI operating in these sort of open-ended games that maybe not fully open-ended, but obviously much more complex in action space and in environment than things like Go and chess. So this is a lot of fun to kind of check out. In a more sort of traditional way, I'd encourage you all to check out this really great paper that was written by the creators of Project High-Rise, which talks about how in this game they actually simulated up to 1,000 NPCs, and this was done in sort of a really simplistic way of the sort of like what's called a behavioral tree. We'll talk about those in this course, and sort of a objective-oriented way of determining what to do next, and sort of like a simple, almost like a set of instructions that each NPC has to process. But 1,000 NPCs simultaneously trying to hit 60 frames per second, interacting with one another to some degree, and with the environment, and an environment that a user is changing constantly is not a trivial engineering task. And so they go into detail about the design of this system, and shows just how, even though this is not like reinforcement learning, it's not AI, it's not like deep learning or anything, there's really complex emergent behavior that comes out of what is essentially a heuristic-based approach, which is really cool. Just to kind of call out The Sims, a lot of AI in The Sims. I actually had the pleasure of talking to some of the Sims developers, and it's just the amount of testing that it's never ending, As soon as they add like some item, they have to test another billion hours to make sure that it doesn't break something unexpected because of all of the funky interactions and dynamics in the game. As mentioned before, Grandmaster AI for StarCraft 2 from DeepMind, the ability to, these AIs are able to essentially beat some of the best players in the world at StarCraft 2, which is quite a little bit scary, but at the same time, it's a very exciting demonstration of what some of these technologies and techniques can accomplish. And then finally, encourage you all to check out this talk at GDC about utilizing deep learning techniques to detect and then combat cheating in kind of high stakes games like Counter-Strike Global Offensive. So yeah, check it out. A lot of this stuff going on. Happy to kind of point new things out as we go through the semester. But if you all find interesting examples of AI being used in game development, in games themselves, feel free to post it in Discord. I'm happy to do even custom lectures on different subjects that you all are interested in, or things that come up, or if you'd like to kind of dissect interesting papers or interesting things that you find. So yeah, that's it for this week. And I'll see you next week, which is probably this week because I'm a week late. Cool. See you later.